Hi everyone, I'm John Hall, an application engineer at TriMech, and today we're going to take a look at a brief overview of SOLIDWORKS Inspection. SOLIDWORKS Inspection is a quality control documentation software for generating out reports for use downstream for things like quality, inspection, and tolerancing directly off of your SOLIDWORKS drawings and also off of PDFs. So what we're going to take a look at is a brief overview of how the software works and some of the functionality that you can get out of SOLIDWORKS Inspection. As of today, a lot of companies will typically do inspection manually, and they will typically do things like hand ballooning on a print, manually doing inspections and then entering in data into a piece of paper or into an Excel spreadsheet. And what we're going to take a look at is how that can be automated to actually synchronize up your drawings, as well as reduce the amount of errors and inconsistencies in the model. So SOLIDWORKS Inspection allows us to automate both the ballooning and report generation directly off of drawings. And this allows us to do all of this information directly off of either SOLIDWORKS prints or PDFs, as I said before. And what this allows us to do is to conform to any sort of inspection standards like AS9102 for aerospace or PPAP for automotive. One other key aspect to SOLIDWORKS Inspection is that you can also import that data and merge it together with things like CMM or digital calipers to track the measurements on your quality documentation. And what we're going to do is take a look at 4 key areas in the software. We're going to take a look at capturing characteristics directly off of a PDF, and then we'll also be generating out reports, things like Excel spreadsheets and ballooned documentation for downstream. Next, we'll take a look at how that can be automated directly off of a SOLIDWORKS print. So rather than painstakingly entering information, we'll take and leverage our pre-existing SOLIDWORKS data and pull that directly into an inspection report. And finally, we'll take a quick look at how you can pull in inspection data directly into those reports, whether it be CMM, digital calipers, or manual measurement information. So let's take a look at how a PDF is ballooned inside SOLIDWORKS Inspection. So what we're going to take a look at here is a PDF document, and this is a drawing of a simple aerospace part. And what we're going to be taking a look at here is how you can automate and pull directly from the PDF information that's critical for inspection downstream. So what we'll do is we'll extract some information directly off of the PDF. To start, we may want to capture very critical information such as the part name, the part number, the revision, and things of that nature. So what we can do is we can capture that information directly off of the SOLIDWORKS print. So if we want to capture part name, it's simply drawing boxes around the relevant information that we want to capture into the software. Next, we'll take a look at how to capture critical information and characteristics directly off of the model dimensions. So what we'll do is we'll zoom in here, and we'll capture some of these characteristics, such as these dimensions here. So you'll see that this captured this information directly off of a drawing and automatically converted it to text. What this is doing behind the scenes is it's using optical character recognition software, or OCR, to automatically convert an image into text. So you'll see here it will calculate things like the value, the plus tolerance, the minus tolerance, and then calculate your upper and lower limits from there. This is a great way to automate any sort of inspection directly off of a PDF. There's further things we can do. For instance, if we want to adjust and add more characteristics to this, such as the operation and how this was created, let's say a milling operation, and we want to classify this dimension as critical and pre-describe a method for inspection like digital calipers, we can enter in all that information directly into the report. So next we'll take a look at capturing a GD&T symbol. So anytime that you have geometric tolerances, you can capture that information as well, just by simply drawing a box around that. You have lots of different options for how these get captured, and you'll see here that by default we have this set up to cprint for GTOL. Some companies will actually go in and utilize a true frame callout like here. And so you can build that type of intelligence back into your GD&T frame as required. You'll see here it's automatically calculating my upper and lower limit for this surface profile geometric tolerance. So next I want to capture this radius value over here. So I'll just extract that dimension, and you'll see here that it's going to automatically do things like recognize the number of instances by filling out a quantity, and it will also calculate that this is a radius just by seeing the R symbol. So special characters for things that are nonlinear, like radius and diameter, will automatically calculate and call out appropriately in your reports. So that's just a quick dive into how we can generate information directly off of a PDF. And what this really allows us to do is to reduce errors based on hand calculations or manual data entry that we typically see on the quality control side. This also allows us to reduce the time to market because we're not manually writing any information, and all this quality control documentation is coming directly off of the print. So next, let's take a look at how to generate a report once we have all this information captured. So what I'm going to do here is I'm going to take a look at SOLIDWORKS inspection and generate out a ballooned PDF as well as an inspection report for downstream. Okay, so now that I've got the balloons done and the characteristics captured, we can go ahead and generate out a report from this print. So what we can do is we can generate out both a ballooned PDF and an Excel document on the fly. What this allows us to do is generate out the ballooned PDF as required. And what we can do is we can also generate out our Excel report directly off of the inspection information. So you'll see here I have lots of different choices for how this report gets captured, and you can adjust standards like AS9102 or PPAP, or even create your own Excel form to work with. So we'll be generating this out as a typical AS9102 document for aerospace. So here's our Excel form here, and you see it automates generation of all of the characteristics and captures out all the information I need for generating an inspection report. So that's how the reports are generated from SOLIDWORKS inspection. And you can see it's an automated process, so there's no manual data entry. This allows you to conform to any sort of industry standards that you want, such as AS9102 or PPAP, as I said, and it also allows you to generate out multiple inspection reports for things like first article, critical inspections, or even in-process inspections as needed. So next, let's take a look at how this is done from within SOLIDWORKS. This will be a much faster process because we already have all of the information in SOLIDWORKS drawings as intelligent dimensions, rather than a PDF, which is a typical image type of capture. So what we'll take a look at here is how that information is generated automatically from a SOLIDWORKS drawing in just a couple of clicks. So what we'll do is we'll start capturing this information from these SOLIDWORKS dimensions. So to do this, we'll just simply start an inspection project from within our inspection tool. And this will allow us to pull forward any relevant information I need for the report, such as the part number, the part name, the rev, the doc number, etc. And what this will then allow me to do is pull in any relevant dimensions that I want, such as reference dimensions, basic dimensions, GD&Ts, things of that nature. And then it will go ahead and set any default block tolerances. I can override this as needed, but at the end of the day, it's just a couple of clicks, and this will allow us to generate out our ballooned drawing in a fraction of a second. You'll see here that it ballooned all of the dimensions, and it pulled forward all of the relevant inspection dimension I need for a report. I can go ahead and change any of this or add any additional information to each dimension as required, but once I'm done, I can then export this out to a ballooned PDF as well as an Excel file. So just like before, I can export an Excel file directly out of my SOLIDWORKS drawing. And you'll see here that that generated out the complete inspection documentation as required downstream. So that was how a drawing gets captured inside of SOLIDWORKS Inspection directly from within a SOLIDWORKS model. So you can see that there's a seamless integration into SOLIDWORKS, which allows me to automatically generate all of that relevant information for downstream quality control. And it also generates out the reports as required, just like before. So what we're going to take a look at next is validating this information with actual measurements. Now that we've got a report generated, we're going to actually take some measurements off some real-world parts and enter that information in to check and see if we're good or our parts need to be scrapped. So what we're going to be doing today is taking a look at inspecting with calipers, which have a USB interface directly into my computer. Now you may have other types of inspection tools, things like CMM for coordinate measurement machines, or maybe a tool like a ferro arm or something along those lines where you're actually doing inspection directly off of a part. Or maybe you're just taking manual measurements and entering in that data. Whatever it happens to be, all that information can be pulled directly into your SOLIDWORKS inspection reports to calculate if the parts are actually within your tolerance range. So let's take a look at how that works with an actual model. So here we have some digital calipers, and you can see they're pretty straightforward off-the-shelf digital calipers, and they have an attachment that will connect up to my computer called an SPC connector. This will connect up to a USB drive on my machine. This will actually interface with the SOLIDWORKS inspection software. So very simply what we're going to do is we're going to select the dimension that we want in SOLIDWORKS, and then we will come over here, measure our part, and with this interface we can actually press the button to populate the information directly into SOLIDWORKS. Okay? So you can see here that the dimension actually went to a green color, indicating that that dimension is within the tolerance spec range of my callout. So I'll go ahead and just measure the rest of these dimensions. So here we'll measure part number 2. And finally, part number 3. And so as you can see, part number 3 was outside of my tolerance spec range, indicating that that's a bad part and it's not going to pass my inspection test. So you can track all of these inspection runs and all of the dimensions as required directly inside of SOLIDWORKS Inspection, and even publish that information out into your final report. And so you can see here the report actually has all of the relevant inspection information I just captured. So that's how you can interface with any sort of measurement information that you want once you've got your report generated. Whether it be digital calipers, CMM, or even hand calculations and manual data entry, you can still track that information to see whether or not your parts are within your quality range or outside of the tolerance zone. So whether it be digital calipers, or even something like a CMM or a ferro arm, or something simple like manual data entry of those dimensions, you get really nice visual feedback of whether or not your parts are inside your tolerance range or outside of your tolerance range, with green indicating good parts and red indicating bad parts. So to summarize, what we took a look at today was ballooning PDFs, which really allows me to eliminate a lot of manual data entry. We then automated the reports, which will actually allow us to conform to any sort of inspection standard we need, whether it be aerospace, automotive, medical, or what have you. And then we also generated our inspection document directly off of a SOLIDWORKS drawing. And you can see that that's a really easy way to generate inspection reports, but it will also synchronize with your design. So as your design changes, your inspection documentation can update and change to match. And then finally we took a look at a quick validation using some digital calipers, which allows us to automatically analyze the measurements on the shop floor. So as you can see here, SOLIDWORKS Inspection can take what used to be a very long, intensive manual process and cut it down into an automated process. Pacific Bearing Company was able to actually cut down on their inspection generation time from an entire day to around 5 minutes. So that's been a quick overview of SOLIDWORKS inspection. If you have any questions, please reach out to us. We'd be more than happy to answer them, as well as show you a deeper dive into SOLIDWORKS inspection.